This video is on orbital filling diagrams. You're going to want your periodic table out during this video because I'm going to show you a different way of writing an electron configuration. So what we're going to do is instead of writing like 1s2, 2s2, 2p6, etc., we're going to use lines or squares to represent what we call the valence electrons. So it's really important that you know this term, the valence electrons, and I'm gonna write it in purple right here. The outermost electrons are what we call the valence electrons in the outermost energy level. So that would be furthest away from the nucleus. We're going to use lines and squares to represent those orbitals in that energy level. So we're going to use lines and squares, and then either on the line or in the square, we're going to draw arrows, or we're going to draw half arrows to represent the actual electrons. So we're going to be drawing orbitals. We're going to be writing arrows to show electrons. All right, but the way we do this is we have to follow what we call Hund's rule. And Hund's rule says that every orbital must have at least one electron in it before it will have two. So it's got to be filled singly, so one, before doubly. So it's kind of like students on a school bus. If there are 30 seats on the school bus and it could hold 2 kids per seat, right? That would be 60 seats. However, if only 30 of us get on, we're going to each take our own seat before we have to double up. Then if 5 more kids come on, then they will double up. But you wouldn't necessarily double up until you had to. Okay, so you as a student on the school bus are just like these electrons in their orbitals. They're going to take their own until they have to share. So things are going to look like this with your sublevel. So let's say you have an S sublevel. S sublevel has one orbital. And that one orbital can hold 2 electrons. So to show the one orbital, we're either going to do a square or a line. I'll start with a square. And then to show the 2 electrons, we'd have one with an up arrow and one with a down arrow. If we did lines and half arrows, it would look like this. And I usually do this way because it's quicker. So the line or the square is the orbital. The arrow up and down, each one is an electron. Now they are up and down because inside that orbital, they're spinning in opposite directions. That's why we're drawing them in opposite directions. So for P, if you had P orbitals, there are 3 of them. Oops. And so 2 electrons in each, so that's a maximum of 6 electrons. So if we were drawing these p orbitals, we would draw p, there would be 3 lines, 6 electrons. My first 3 would go in individual ones. If I had more than 3, then I would start to double up. Okay, so remember that D has 5 orbitals, so that would be 10 total electrons. So D would be 1, 2, 3, 4, 5 lines, and that can be 2 in each. And that F would have 7. Ran out of room there. Okay, so let's do a few examples. And here's where our periodic table is going to help. We're going to have to look at that outermost energy level. Now the outermost, the highest number, so like that's that number in front, 4, 3, 2, whatever it may be, is always going to be the row that it's in, just like your noble gas notation. So let's do boron here. So boron is right here. Okay. So boron is going to be, if we do the full configuration, and you don't have to do this every time, I'm just doing it as an example, 1s2, 2s2, 2p1 for 5 electrons. The outermost ones, our valence ones, are only these because they have the 2 in front. They're in the second energy level. We're not going to draw this for our orbital filling. So our orbital filling is going to have a 2s2. So I'm going to draw my 2s orbital. I'm going to label it underneath. and it has 2 electrons. So I've got 1, 2. Then I'm going to, for my 2p, I'm going to leave a little space here. I'm going to write 2p. 2p has 3 orbitals. There's only 1 electron, so I'm going to draw my 1 electron. So this in purple is my orbital filling diagram for boron. Notice I do have to draw these empty ones to show that they are empty and that there are 3 in this 2p. Okay, let's do another one. Let's do sulfur. All right, so sulfur is here. Okay, and I'm not going to write the whole configuration. I'm just going to look at my periodic table, and I'm going to see that 3s2, 3p4 are my highest energy levels because below that is 2 and 1, 3 is higher. So I have 3s2, 3p4 that I'm going to draw. So I label 3s, and it's 2. So I draw my 2 electrons. I'm not writing a 2, notice. I'm not being redundant. The electrons show 2. And then I said 3p4, right? Okay. So then I leave a little space. I write 3p. Here's my 3 orbitals. 4 electrons. 1, 2, 3. And then I'm going to go back. 4. This would be incorrect. If I wrote 3p and I did 1, 2, 3, 4, this would be wrong. Because remember that Hund's rule says that they have to each fill once before they will double up. All right, let's do one more. Strontium is right here. So we've got 5s, right? Everything below it is 4p, 3d, 4s. So 5 is my highest. So it's 5s2. So I'm going to write 5s. Here's my orbital, 2 electrons. So these are orbital filling. Now, one